Thanks, Eric, and thanks for also Jesse for organizing this great conference. I've never been to Burlington before, but this is great. I hope to come to this conference again. You got a little bit of an intro. Let me just do my quick intro slide, a little bit more about me. For the past 20 years, I've worked in Silicon Valley research labs, Xerox PARC, Yahoo Research, and now IBM Research in Almaden. You can see that California is always sunny. And I'm a sociologist. So this morning we heard from Victor about applying psychology to design. I'm going to talk about applying sociology to design. My PhD is in sociology, and I study the intersection of, my work is at the intersection of social interaction and technology. I've done work practice studies where I follow around workers with cameras and record how the work actually gets done in a variety of settings. I've done studies of technology-mediated social interaction between people. For example, one big study was on social interaction in virtual worlds through avatars. I'm probably addicted to video games too. And more recently, I've been, I also look at human-computer interaction. When I was at Yahoo, I was looking at users interacting with search engines using eye tracking and some other methods. And now I've been particularly interested in the last 4 years in these kinds of things. You can see there's an Amazon Echo device, which has got my conversational agent running on it, and I've been looking at natural language interfaces. And the reason I'm so interested in those is because my background within sociology is in a field called conversation analysis. And you probably haven't heard of it. It's a pretty small subfield of sociology, but to give you a little background, it was founded in the late 1960s in California by Harvey Sachs and Emanuel Shegloff. And the thing that really motivated them, these are sociologists, they're not linguists, but they were inspired by the idea that with a compact cassette recorder, which I think was a fairly new technology, at least for the masses, you could capture forms of social action and social interaction in a way that you could take it back to the lab and dissect it. You could replay it over and over. You could transcribe it in detail. And most importantly, you could play it for somebody else. And share their analysis, and they could agree with you, or they could disagree with you, because they can see the underlying data. And this was a thing that was missing from a lot of studies of social action and social interaction. It was this record of what actually happened. And so that was kind of motivating for the whole field. And so, yeah, that's my training. And everything I study with at very least with a conversation analyst's sensibility toward data and interaction. So, and I'll tell you more about how I've applied this to design. So the systems I'm interested in are these kinds of things. So we all know an Amazon Alexa. And I tried to look for, like, what's the most recognizable chatbot? And I couldn't really come up with one that everyone would recognize, so I just picked a screenshot from one of our systems. But I assume you're all familiar with chatbots as well. In fact, how many people have designed or built a chatbot or a skill for a voice assistant? Not too many. Okay, so everything I'm going to talk about is most relevant for you two people. Well, hopefully it'll still be interesting. And anyway, in research, so in IBM Research, I'm in the research organization. You know, it's a great job. Our job is to invent the future, or at least to try and invent the future. And so usually what we're looking at are things that are a few years out and are coming, maybe coming, we'll see. So maybe in the near future you'll be working in the space, maybe not. It's an exciting time because, you know, this technology is taking off with advances in natural language understanding techniques using machine learning, as well as far-field microphone arrays that enabled you to talk to a smart speaker from across the room. And so, you know, at this latest stage of this technology, that we can do new things we couldn't do before. But it's a hard kind of interface to build. But my main question for this talk is, in these kinds of systems, what is the UX, and how do we design for it? So you take this smart speaker. Surely part of the UX is the physical device. And in fact, they've got a really nice a ring of light at the top that changes state in all these ways to show you how whether the system can hear you and what it's doing. And that's part of the user experience. Or, you know, the familiar chat window, right, with the chat history and text entry box type here. That's part of it. But that's not really what the user experience is about, right? That's not the main user experience. The main user experience is the exchange of utterances in this interaction, the sequencing of the things that the user says and the things that the agent says. That's really the primary part of the user experience. And so the question is, how do we design for that? What design knowledge do we apply for that core user experience? And as an analogy for a minute, I'll take something that's more familiar to all of you. Web design. Let's think of web design for a minute. So this is a shot of the screenshot of the IBM website in 2016. And to a layperson like myself, it looks pretty good. I mean, it looks, it's pretty flashy. It's pretty clean and slick looking to me anyway. Everyone in the audience could probably tell me technically the features that it has. Tell me about the cascading style sheets and the color palettes and the typography, as well as the interaction mechanisms like the search box. We've got pull-down menus, social media icons, and I learned somewhat recently there's the hamburger menu in the upper right? The hamburger menu. And my point is, there are people like yourselves who can describe this as a technical object. And there's a shared set of practices and knowledge about how to build these things. And in fact, I can hire a web designer to produce something very much like this. But that was not always the case. I mean, if we go back 20 years ago, the IBM webpage looked like this. Right? This looks like kind of like a glossy magazine, right? This looks like a bad PowerPoint slide. And it's not, this is professionally designed. This is not. I remember designing web pages like this. Netscape Navigator had an editor with it, and so anybody could create a web page, and most of them looked kind of like this. The point is, how did we get from here to here? And there was a lot of things involved, but one thing that was involved is that we learned that we could take formal knowledge from graphic design and apply it to this new medium. Now, we couldn't just import it exactly because there's things very different about a web page than from print, but there were a lot of things that we could use to inform that. Things like understanding of color and typography, et cetera, et cetera. But for a conversational interface or a natural language interface, that kind of formal graphic design knowledge isn't going to help us much. We need something else. And so I would argue that with natural language interfaces, we're kind of back in 1996. For like the web, where the technology is out in the hands of the masses. People are building things, but there's not yet a UX design practice around it, the conventions, the standards to support it. And that's what I would argue, and that's what we're lacking right now. And the question is, how do we get there? We can't just do what we've done in the past. We need to find something new. And my argument is that for this new conversational UX designer, we need to combine knowledge from UX design as well as from social science, not from the visual arts or the graphic arts or the graphic design and even industrial design. I mean, maybe for parts of it, maybe for the physical device, maybe for other parts of it. But the core, we need to know something about how conversation works. And some social sciences, such as conversation analysis, can help us there. They can give us new vocabulary, or I should say they can help us invent new vocabulary principles and new patterns, because that's what we're going to need for a new design discipline. So let me introduce one new concept, natural conversation. Now, it's not the same as natural language. Part of what's made these interfaces popular right now, or feasible, is advances in natural language processing. Well, natural language processing is all about English or Mandarin. Natural conversation is something more. It's a particular kind of natural language use. And so if we look at natural conversation, there are multiple components. There's the language part of it, what language are they speaking? There's a knowledge component. What are they talking about? Are they talking about travel, healthcare, entertainment? But there's also an interaction component. And I would argue this is the missing piece right now. We don't provide tools for developers or designers to design the interaction. I mean, what is the user and the agent doing? Are they doing troubleshooting? Is it a debate? Is it Q&A? Is it a quiz game? Is it counseling? Is it tutoring? I mean, all of those activities have a different interactional shape. Instead, we give the designer a blank page, and and rely on them to figure it out using common sense. And so this is the piece, the leg of the stool that I'm going to try and provide some support from using conversation science. So, so given that people at this time are experimenting and building different kinds of systems, we see different kinds of interaction models underlying these natural language interfaces. One kind of model you typically see is this. Basically, everything that the user says is treated as a question or a command or a query, right? You get a response, and then if you get a response from the system, you don't say thank you, right? For example, Google would go and look up thank you and show you, search results for thank you, right? It doesn't have the notion of that. Everything is a first, and everything is like I said, a query, a question, or a command. This is great from a system perspective. It's much cleaner and simpler to implement this than some of the other systems. You're basically requiring the user to form a fully adequate query. If they do that, they'll get good stuff back. If they don't, they'll get back garbage. You often get this kind of user experience when, by default, the system developer was designing the user experience. Now, whether they knew they were designing it or not, they were. It was determined by them. And I've seen a lot of projects where there was no UX designer for this. Right? It's by default being designed by the decisions being made by the software developer. So that's the first kind of interaction model. Another one is like this. This is where the content is the most important thing. You'll see this, for example, when an FAQ is easily converted to a conversational agent. The user asks a question or makes a request, and they get a big, long response like this. It's always in text, because this is not feasible with voice. This is too unwieldy in voice. And you get this also often when, like I said, when the content is most important. So sometimes, like with insurance companies, they want to make sure that they tell the user everything, and they might even by law have to tell them certain things. And so they'll have a subject matter expert writing these things, and this is the kind of user experience you get as a result. It can only be done in text. And basically, you're reading a short document, right? It's a paragraph. Another kind of interaction model you get is this. User asks a question or makes a request, they then receive a set of buttons. The buttons show them the kinds of answers that they can get or show them the kind of questions they can ask. User selects one and they get an answer. These kinds of interaction models you get when known principles and practices from conventions from visual UX design are applied to natural language interfaces. Right, so in that case you've got, it's basically informed by visual or GUI design. And the final kind of style is the one that I'm focusing on, which is conversation-centric. It works more like a conversation. You have, first and foremost, what the user says is taken in the context of what was said before. Right, the context is persisted across turns and used as a frame of reference. So if I say okay or thanks, it'll be interpreted in terms of what came before. Now that's kind of hard to implement. So it's much easier and cleaner with the system-centric, to just ignore that and not persist the context. But of course, that's how people talk. We inherently build on what we've said before. We can say things like, what about Paris? And given that I was just asking for things to do in London, I recycle that context. And in fact, we're pretty lazy when the way we speak naturally. And we do that kind of thing all the time. Harder to implement, but more like a natural conversation. And things are short, right? The utterances that both the user and the system produce are relatively short, because that's how we talk. And so just to clarify, this is the kind of thing that I'm interested in building. Now, I'm not going to argue that this is the only way to do it. And I'm certainly not going to argue that these other styles aren't useful or efficient. I mean, a search engine basically uses this first kind of style. I've never argued that a search engine is not useful, right? But if you're interested in the problem of can we create a machine that can talk in a natural way to us, like we talk to other people, then these are the kinds of things you have to consider. And I think on the one hand, we've always wanted to do this. I mean, look at science fiction for forever, right? We can talk to a machine just like we talk to other people. I think we'll always want to do that. But there are other advantages as well of this kind of style. And let me get into that. So this is a screenshot of one of our agents that is a virtual or an automated travel agent. And you had this kind of conversation, tell me about your trip, I'm going on vacation to Europe. What kind of things do you like to do? Like historic places, museums. Okay, my top recommendations are London, Paris, Rome. Thanks, you're welcome. Now, one thing you get with this style, I mean, it's like a conversation, right? It's conversational. One thing you can do with it is you can use it with voice. This is entirely voice-friendly. You can use this on a smart speaker. Or you can use it on a voice-only device. Or you can use it on a telephone, right? It's voice-friendly. You can also use it with SMS, right? Because as SMS, you pretty much just have control of the words, right? So it works with that too. But if you have more screen real estate, you can do more. So the actual system interface looks like this. And we have more screen real estate, and so we can provide more information. We can provide graphic elements like photos and maps, and we can do things like have an extra way of highlighting the entities that the system recognized, which in a lot of ways work kind of like filters, so we can bring attention to that. Or we can provide here, we have a ticker that gives examples of things you might say at that point in the conversation, which change at each point in the conversation. But it's they're kind of like tooltips, really, in a way. It helps teach the user how to use this thing. When they know how to use it, they can turn that off so it's not distracting, right? Conversation is the same, but it's enhanced with visual aids, just like how I'm talking right now is enhanced with visual aids. In between, you might have a mobile interface, and this is another one of our agents that helps you with your itinerary and sort of places to go when you're in a travel location. Because it's mobile, you have space for more information, but it's more constrained than that big desktop. If you tap and open a drawer there, you can talk to the conversational agent. Because it's mobile, we can do more, like we can put in those scrolling tips or the ticker that we couldn't do with SMS or with voice. So, taking this all together, we advocate a conversation-first approach to design and development. Very familiar, right? Very much like mobile first. But it's conversation first, and what that means is that the interaction is fully functional through the words alone, right? If a natural language or a conversational interface it's primarily the words themselves. And if you do that, you can use it in all kinds of different situations, and the user experience of the conversation will be the same across them, although they may be enhanced. And so you can, as you gain screen real estate, you can progressively enhance it. And so then the user gets a consistent experience in talking to the agent. The agent works the same way, sounds the same. If you do that, you can use it, if you have an advantage of the conversation style is you can use it across all these different kinds of platforms. Okay, so that's the first point, conversation first. Next thing, how do you build a conversation? It's kind of like Blockhead. Does anybody know Blockhead? Does anyone? Okay, a couple. I played this when I was a kid, which shows how old I am. I'm very, very old. It's kind of like reverse Jenga. With Jenga, you take blocks away. With Blockhead, you put them together, and you're trying to build. In both cases, you don't want it to fall down, but you build it up. You take turns going around, and somebody places a block, and then the next person places a block on top of that. When you place a block, it constrains what the next person can do, but it doesn't determine what they can do. And that's not unlike a conversation where we take turns, except in this case, the blocks are utterances or turns. I'm going to use turns and utterances interchangeably because we take turns producing utterances. But turns make up sequences make up activities, and activities make up a conversation. And I'll show an example like this. We've all had this kind of conversation. Hello, hi, how's it going? Good. Hey, are you going tonight? Yes. Can I get a ride? Sure. What time? 7 o'clock. Okay, thank you. Right, we've had this conversation, and if we look at the anatomy of it, at the low level, we have the utterances or the turns that are taken, that are produced by different parties. If we go sort of a level up, those form sequences. We have a greeting sequence, then a welfare check sequence. We have then a request sequence and an inquiry sequence, right? So a sequence is made up of more than one utterance. And then at the next level up, we have activities, right? Here we have 3 activities: opening the conversation, closing the conversation, and then in the middle, some business. In this case, requesting a ride. I want to get a ride tonight. And so that all of that together makes up a pretty short conversation, right? So the first thing I realized when I started working with different teams in IBM that were building chatbots and conversational or natural language interfaces is that the different teams didn't even have a vocabulary for talking about the pieces of the thing that they were building. across the teams, they were using all kinds of language to talk about turns or sequences or a conversation. A conversation meant all kinds of different things are a conversation. And so I realized even just taking the vocabulary from conversation analysis, even if you didn't say anything more, would be useful because it would give a standard vocabulary. But there's more than that. There's more we can get for conversation analysis. So the next thing. So we can also get principles from conversation analysis. And the first is that conversation is efficient. We often don't think of this when we think of like typing natural language responses. In fact, typing language is very slow. But natural conversation is very efficient in the way we design it. And so one principle from conversation analysis, and by principle, really what this is a description of what people do. This is how people design their own talk. So, but we can use these as designers when we're designing a person, basically, to talk, right? When we're designing an agent, we should follow the principles that we naturally use as speakers. And so the first is recipient design. We tailor the utterance so that the particular recipient, that is the person we're talking to, can understand it. For example, talking to person A, and I know that they know Dave. Dave's my neighbor, who's a contractor, and if I know that person A knows Dave, I'll say, hey, Dave's doing my bathroom remodel. Actually, he just did it, and it looks great. But if I'm talking to person B and I know that they don't know Dave, then I'll say, my neighbor across the street, his name, I may or may not say Dave, I may say, my neighbor across the street is doing my remodel. Right? For them, I design the same utterance differently. I mean, the purpose of the utterance is the same, but I design it differently based on what I know or what I think I know about those two recipients. So that's the first thing, is tailoring. And this is really hard, actually, right now with natural language interfaces. And I would argue we don't really have the ability to design the utterances for each particular recipient. I think we'll get there. But currently, we do try and design for the audience, right? If we know good UX design, we know something about the users, and we design for those users. So we can do that to some degree. The next principle is minimization, and this is where the efficiency comes in. And that is to use the fewest words necessary without sacrificing number one. So the most important thing is that recipient understand, but do it efficiently. Use the fewest words that you have to. And then try it out. And then say the thing and see if it works. And if it works, great. You've made it a little more efficient. If it doesn't, then the third principle is repair. And repair involves redoing the utterance and relaxing number two if the recipient encounters some kind of trouble. If you're repairing it, then don't worry about minimization. Use as many words as you need so that the user can understand it, because understanding is the most, or that the recipient, understanding is the most important thing. So for example, with our agent's name, Alma, if I ask Alma, what's your favorite movie? It will say, I guess I like movies with a strong AI lead. If you say, what do you mean, or I don't understand, it will say, I like movies in which the main character is an artificial intelligence. Oh, okay, thanks, right? So with repair, you can see that minimization is relaxed. The acronym AI is expanded into what it stands for. Main character is used as kind of a simpler version of lead, right? Netflix always going on strong female, movies with a strong female lead, right? Well, main character is kind of a simpler version. And we use this, if we have to elaborate, we use a longer, simpler, clunkier version of the utterance. Because the point is to get the user to understand. And so this is a mechanism that makes a talk efficient. We try out the concise version first, and then we repair if necessary. That means in most cases, we don't have to use the long, clunky version. In most cases, the concise version works. And then if there's, but then we can still fall back on repair if we need to. So this is a mechanism. I assume these are probably kind of new principles for most of you. For conversation analysts, these are some of our basic principles. This is how we design talk. We're going to design an agent that can talk in a natural conversation. We need to understand these things. So we have, like I said, our agent, the kind of code name is Alma, short for Alma Den, where we're located. As a native Californian, we consistently mispronounce Spanish words, so it probably should be Alma, but I say Alma. And it is one implementation of what we call the natural conversation framework. And I need to clarify here, in talking about this work, I'm not speaking for IBM. I'm speaking for work of my team in research. There's a lot of stuff that happens in research that never makes it to product or whatever. I mean, there's a long path from research to product, and so I'm certainly not talking for any IBM product or business units. We'll see what happens, but just speaking for our team here. And so we've developed what we call a natural conversation framework. It's generic. You can use it on any platform. We've implemented it on 2 IBM platforms. First, Watson Dialogue, and then the newer one, which is Watson Assistant. So Alma is the name of this system on Watson Assistant, but you could implement much of it on other platforms like the Alexa or Google Assistant or Microsoft Bot Framework, et cetera, et cetera. And so the different parts of this are, there's 4 main components of the framework. Now, this is a design framework. It's not a software framework. It's not an SDK. It's a set of principles, concepts, and most importantly, patterns, UX patterns, or I should say interaction patterns for designers, for the designer who may not quite exist yet, but for the designer who wants to create a conversation-like user experience. And so I'll talk about the interaction model. There's a content format, or maybe content outline, as Lisa would call it, which I think I will skip just as a matter of time, but I can talk about that offline. There's pattern language, which I definitely will talk about, and a navigation method, which I'll touch on quickly. So let me take a little drink here. So back to the interaction model of the conversation-centric style. So, right, so all the systems currently at least have a 2-turn interaction model, where you get things like requests or questions, and you get from the user and from the agent, you get an answer or a granting of the request or fulfillment of the command or whatever it is, right? Everybody has this. It's a simple sequence, and this is absolutely part of natural conversation. But in human conversation, there's more to it. The interaction model is a little more complex. There's a lot of talk that we do in service to this sequence. We call these kind of sequences adjacency pairs. They're paired actions that are recognizable. I request something that then to you makes it relevant to either grant the request or to deny the request, but it makes relevant some next action. They're recognizable, right? Greetings, invitations, right? These are all kinds of paired actions that are recognizable. And we call this kind of sequence the base pair. And the base pair can have supporting talk that is in service to that base pair to help the speakers accomplish it, because it's an accomplishment that sometimes works and sometimes doesn't. So let me show you a longer transcript of talk, the supporting talk you get around these kinds of pairs, and we call them expansions of the base pair. And I'll play a recording of me talking to Alma, talking through this transcript, and then I'll analyze it for you. So let's see if we've got sound loud enough. Do you know about restaurants?
I know a few places.
A few what?
Places.
I need a place to eat that's nearby.
What kind of food do you want?
Well, what are my choices?
Around here, Mexican, Japanese, or Indian?
Mexican.
Mezcal is located on West San Fernando between South Market and South First.
What do you mean?
The Mexican restaurant, Mezcal, is located at 25 West San Fernando Street between South Market Street and South First Street.
Oh, okay. Thanks.
You're welcome.
So it's all ordinary kinds of stuff. It's a little slow, and the speed, maybe this gets to immediacy, the speed of human conversation is very fast, and that's something right now that's very hard to simulate in these systems. So we're not quite there yet. I could talk more about why that is. But the other kinds of things are very ordinary things. So for example, do you know about restaurants? We call this a preliminary. You're expanding the base sequence before it's even happened. And what you're doing is you're checking the conditions upon which the request depends. So if you don't know about restaurants, I'm not going to ask you for a restaurant recommendation. The canonical preliminary is, are you busy tonight? Right? You hear that as not just an inquiry in itself, but as a preliminary to some kind of invitation or request. And if in fact you say, yeah, I'm busy tonight, then you may not get the invitation, or you'll get it in a very different form. Oh, I was going to ask if you wanted to go see a movie. And so those are pre-expansions. They're preliminaries that do the work of screening the conditions for that first part of the pair. It's working in support of that pair to try and accomplish it. The next expansion we get is a few what, or similar things are what did you say, or places. These are a set of repeat techniques, and it's a form of repair, like I was mentioning earlier, that serve to repair troubles in hearing. Right? After any turn in a voice conversation, the recipient may have trouble hearing what the other person said. They may not have heard any of it, or they may not have heard part of it. And this is a neat little technique here, where you can get the speaker to repeat just the part that you missed. Right? A few what? You recycle those words a few, with it then a question word, and then they just say places. So that's efficient, right? Saying just places instead of I know a few places is another way that natural conversation is built for efficiency. You may need these are very important because in a voice situation, you may get them after every other turn. I mean, imagine probably later when we're at the social, or if you're in a bar or at a concert, you get a lot of these because the other person just can't hear it. And if they can't hear, then they can't do the next action. They can't grant the request, or they can't, whatever the next action is, they can't do it. All right, we also get expansions that happen in the middle of the pair. What kind of food do you want? Right? When we talk to somebody, we always make assumptions about what they know. Right? For example, I assume that person A knows Dave. Now, they may not know Dave, or they may not recognize Dave. But we have these ways to elicit details that enable then the participants to accomplish it. And so this is actually known. So these are known as slots. So on Alexa or Watson Assistant, or I think the others as well, they're known as slots that go with an intent, and that if you may design it so that if you're going to give a restaurant recommendation, you require a cuisine preference, right? And it will elicit that from the user. Now the thing is, the user might need to do that too. Well, what are my choices, right? Either party may need to elicit additional details. And because there's always assumptions about what they know or may know. And the point I'll make is that all of these expansions are slots. There's not just one kind of slot. They're all slots for additional actions. We get a food preference, and then you get the granting of the request. Mezcal is located in West San Fernando, but we're still not done, right? What the user in this case, or the person who made the request, what they do next is critically important, right? So if they say, "What do you mean?" That's a problem. Right? That's the other kind of repair. The other kind of repair is when I'm having trouble understanding you, right? And I heard what you said. I heard the words, but I don't know what you mean, right? So I need some kind of paraphrase of all or part of the previous turn, or maybe an example or a definition. So there's a set of repair techniques that deal with paraphrases. And that's important. Or you get then finally things like this. Okay, thanks. You never get thanks first. Thanks inherently comes after something, and it does, in part, the work of closing that sequence, or other things, what we call sequence closing thirds, like okay, good, great, assessments, et cetera. They do the work of closing. So these things like okay, which a lot of systems don't recognize, do critical work in terms of managing that sequence. It's a way of saying we're done. So in our framework, the interaction model is that of expandable sequences. You have a base sequence that can be expanded through a set of various kinds of expansions that do this kind of conversational work. That's part of what makes it a conversation, right? If I can't say, what did you say? Or okay, and you don't understand, I mean, it's not really a conversation. It could be some kind of natural language interaction. It could be very useful, but it's not conversation. It's not really conversation. So you can think about it kind of like an accordion, right? In some cases, you'll get user A, and they say everything just right. They can hear easily. The accordion is closed, and you just get the two parts of the sequence. Or user B, they don't quite understand this domain, or they can't quite hear, and the accordion is expanded, like that case I showed with all those different kinds of expansions. There's something in between, and in that way, we can kind of personalize the content for the users, not within the turn, but between turns, right? User A is an expert user, doesn't need any additional help. User B is a novice. They don't even know what things are called, and so with that, we can instead of giving both of them the same amount of content, we can enable them to customize their experience of the content, control the amount of content that they get. One last reason that this is important is that it enables what we call natural conversation understanding. Now, there's already a notion of natural language understanding, which is what we use, the techniques we use to interpret the individual turn. So if a user says, what's the address for Almaden, there are natural language understanding techniques for classifying that and extracting entities like Almaden and address, and that's critically important, and that's the first step. But there's more to it in the conversation, and that's what comes next. So say the agent then says 650 Harry Road. What the user does next tells us, gives us feedback about whether there's understanding. If they say thanks, great, it means we're done. They got what they wanted. If they say, what do you mean? That means that the user didn't understand what the agent was saying. And if they say, no, I mean web, that means the agent didn't understand what the user said. And if the user says, never mind, that means there's some kind of trouble, lack of understanding, and the user's giving up, right? So what happens in that third position is critically important. Usually what we do is we use the, was this question useful, right? We just use that one question. But natural conversation has more fine-grained indicators of understanding. So this is critically important because with a conversational interface, it's not just important that we give the user accurate information, but that we have some evidence that they understood it. Because right, that's the goal of a human conversation, is that the other person understands. You walk away and you didn't know what I was talking about, I failed. All right, so that's the interaction model. That's really the most important part. And I'll go a little more quickly on the other parts. And I'll skip ahead to the pattern language. So I don't know, how many people know of Christopher Alexander's work on pattern languages? Yeah, there's a few, yeah. He was an architect who in '77 put out a book called Pattern Languages, Pattern Language, Towns, Buildings, Construction, and he had a set of, I think, 250 patterns. And here's one of them, pattern 76, house for a small family. And he gives, talks about that particular kind of pattern, gives some examples of it. And of course, the pattern language contains a bunch of them. And it's not just a set of patterns, but it's a language because they work together, right? They're combinable. And so that was a pretty powerful concept. And I know what I hear is some software engineers like this idea and have pattern languages for software development. Some, I was hoping more UX people also have a notion of a pattern language, not for architecture, but for their own area. So what we did was try to create a pattern language for conversational interfaces, for conversational UX. We currently have 100 generic interaction patterns. Those aren't all the patterns you'll need, but it's a starting set. We plan to expand it and even hope to expand it with the help of a community, if we can get a community of designers working with it. There are 3 kinds of patterns so far. The first kind, conversational activities, those are patterns for the main business of the conversation. It might be, if it's an inquiry, it might be question and answer. If it's a complex kind of request, like booking a flight, that would come under the open request pattern. An extended telling, which I hope I have time to show, is an example of either instruction giving or storytelling. It's a longer unit of talk that takes multiple turns. I'll show you a quiz, inquiry, where the inquiry is where also where the agent is asking the user things. So they're different. That's the main business, and there's others you might need, but those are the ones that we use most. The next class, the other 2 classes are for managing the conversation itself. This is the stuff that's missing from other systems. So we have managing the sequence at the sequence level, so that was like the repair I talked about, or the sequence closers, and then managing the interaction at the conversation level, things like opening the conversation, closing it, or disengaging without closing it. So we have these kind of 3 areas, and within there we have 100 patterns, and I'll quiz you on this at the end. No, I won't quiz you, but just, I mean, we're trying to basically take the science of conversation analysis and make it useful to people like you who are interested in building these systems. There's generic patterns. They're all completely generic. Here's one, or here's 2. So the quiz pattern. The agent asks the user a question, and the user gets a correct answer, and then the agent confirms it. Right, that's the main pattern. A sub-pattern of that, agent asks a question, user gives an incorrect answer, and the agent disconfirms it. And the user can give up, abort the sequence, and then the agent provides the correct answer, right? So let's give an example, or an example of each.
Do you trust Adams?
Oh, cut off a little bit.
They make up everything.
That's it.
Right? Or,
Why can't you trust Adams?
You can't see them?
Wrong. Try again.
You tell me.
They make up everything.
Good one.
right, so that's a quiz, right? It's a very generic thing. You could use it for jokes, and I don't really know of any other virtual agent or natural language chatbot or agent that does jokes this way. They all do one-liners, because one-liners you can do with the system-centric interaction model. But it doesn't have to, it could be trivia, or it could be, say, tutoring, right? You have an agent that that tells the user about physics, and then at the end they have an activity where they quiz, right? They quiz, you'd use this pattern, right? It's totally generic. It's independent of the content or the use case. So if you need to quiz the user, you use this. This is, how am I doing on time? Okay, I'll play this. So the extended telling, this is where you have the agent's trying to say something that takes more than one turn or utterance. It could be a story, it could be a set of instructions. And they break, the agent will say it in parts, and the user at line 3 can do a continuer, okay, yeah. Or can do another action, a repair. What'd you say? What do you mean? And in that way, the user can control the flow of this, say, instruction giving, right? Or the story. And this is important, because especially in instruction giving. Say there's something I don't understand in the first instruction. I don't want to get to the last instruction and then say, oh, by the way, what was going on with the first one, right? You want to be able to repair along the way, achieve understanding along the way, if you have this big, long, unwieldy thing. So I created a little example of a story for you. It should be a familiar story.
A story.
Once upon a time, there was a little girl named Goldilocks who went for a walk in the forest.
Say again.
Once upon a time, there was a little girl named Goldilocks who went for a walk in the forest.
Okay.
Pretty soon, she came upon a house. She knocked, but no one answered, so she walked right in. At the table in the kitchen, there were 3 bowls of porridge. Goldilocks was hungry.
What do you mean by porridge?
Oh, porridge is a dish consisting of oatmeal, or another grain boiled in water or milk, sometimes called hot cereal.
Oh, okay.
She tasted the porridge from the first bowl. This porridge is too hot, she exclaimed. So she tasted the porridge from the second bowl. This porridge is too cold, she said.
This is boring.
Shall I stop?
Yes, please.
Okay.
Right, so you see, now, the pauses are still too long. In this implementation, we're working to get those shorter. They're still too long for natural conversation, which is very quick. But you can see how this long telling, and Alma will tell you the whole story, right? But along the way, you can get a repeat, you can ask for a definition, you can get an elaboration, or you can say, okay, yeah, and get it to move along, right? That's how we talk. We don't do big, long monologues that are monolithic and uninterruptible, unless we're doing something other than conversation. We might be presenting in front of Congress or doing a debate or something like that, right? It needs to be interactive. The user needs to be able to control the talk. And so this is one way to do it. I mean, we're approximating what people do. Really, with human speech, at any point, I can interrupt, say, oh, what do you mean by porridge? So we're not quite there yet. But it's better than the big monologue. And I think, yeah, other systems do. Okay, so that's another pattern. Let me show you two patterns that are related. So if you do a closing to the conversation, goodbye, then you can do some various things. Now, conversation analysts have pointed out that when we close a conversation, we don't just say goodbye, but we actually do a pre-closing. We say, okay then, or is anything else? Or, well, that was great. We do a pre-closing that projects that I'm going to move to close next. And that gives the other person the opportunity to bring up a last topic that they didn't get to mention. And so if they say, if I say, oh, okay, well, it's been good, then we go goodbye, or anything else, no, goodbye. But if I say, anything else, or okay, then you say, oh, yeah, by the way, I called because I wanted to It's a slot where you can do a last action. Well, if we design it like a conversation, we can take advantage of that last topic slot. And so Alma has a design with the last topic slot. If you set it to null, then she'll just say something like have a good day or something generic to close. But you can put other things in there. So for example, you can put what I call a success check or a name request. And I'll play an example of each. So these each start after, so just before the transcript where you can't see, there was something like a question and an answer, or a request and a granting of the request, right? Something was achieved. And then you get okay or thanks from the user. And this is what happens after. So just listen. All right, so here's the examples. I'll play both of them.
Is there anything else I can do for you?
No.
Did you find what you were looking for?
Yes.
Great. Goodbye.
Goodbye.
Now, if the user says no, then we might try and say, oh, well, can I try again, or do something else to try and resolve that. But you could put something else in that slot. You could also put a name request.
You're welcome. Is there anything else I can do for you?
No.
By the way, what's your name?
It's Bob.
Thanks, Bob. Goodbye.
Right. So in this use case, it might be really important for your application that you need the user's name. You might even, in the opening of the conversation, say, "Hi, I'm Alma from IBM. What's your name?" But you can't make the user answer. Well, you could try it, but that's not right. I mean, they may just go straight to the business, and you may miss the name. And so in that kind of use case, you might want to put in a name request at the end. Try the last time to get their name, or something else. God forbid, it might be a promotion. Would you like to hear about our credit card deals? You know, all kinds of things. But this notion of the last topic slot and pre-closing, we get this from conversation analysis by observing what people naturally do. This is something we can use when we're designing our agent. Okay. So those are just 5 of the 100 patterns. I would love to talk about all of them, but I don't have time now. Let me end with one more topic, and that is the navigation method. And I'll just go straight to this. Okay, so with any kind of computer interface, at some point in time you had to learn how it worked, right? First time you used a command line, you learned that even though I have a blank screen, there's lots of stuff there, right? And if I can use these cryptic commands to go to a directory, I can find that stuff and I can list it and I can do various operations on it, right? You had to learn that, and that's kind of hard to learn, but people still, we all still use it. And then at some point we learned about Windows, right? Which we saw the Xerox Star in Nick's talk, which was developed, well, actually the Alto, I think, was the first computer with a mouse and with a graphical user interface developed at Park. I used to get lots of tours at parks talking about the Alto and all this stuff, WYSIWYG editing. Anyway, but there, the idea is that now these invisible files are represented by icons, and the directories are visible folders, and I can drag them around. And this is right, it's a great metaphor, right? But you still had to learn it. Right, it's intuitive and it's kind of like a physical desktop, but it's not, and you have to learn it. We talked a lot about web. I mean, how about video games? Like a lot of video games, not all of them, but a lot of them have a 3D world and a 3D avatar or character, right? And you learn how to move them around through that 3D space. So any gamers know what's this called? Strafe, right? That's right. I didn't know what strafing. I hadn't heard of strafing before until I started playing video games, right? That's how I move my character from side to side instead of turning or going forward, et cetera, right? You have to learn that, and you become pretty good at it after a while. But at some point, you had to learn that, and we had to teach the user how to do that. And video games have lots of tutorial levels on how to do this kind of thing. So my question is, how do you navigate a conversation space? And it is like a space because with much of the technology, all the things that can happen are kind of predetermined. You might insert data into it, but the range of actions is predetermined, and how the user flows through that space is going to vary depending on the decisions they make. But how do you do it for conversation? Well, our proposal is that you identify 6 patterns or 6 actions for the user. There's some of the patterns of those 100 patterns, but 6 actions, like if the user were to only remember 6 things they can do, it would be this set, right? There's more they can do, of course, but this is a set of 6 things. So one thing they can do, teach them that they can always say, what can you do? Right? They can always ask it. This is an action in question that initiates a conversation about the capabilities of the system. This is a big deal for these agents because you can't look at menus and icons to get a sense of all the things it can do. You should be able to talk to it about what it can do, and this is just one way to get into that conversation. It's kind of like the global help. You should also always be able to ask it, what did you say? Or say that again, or please repeat. Because if it's a voice interface, once the system says what it's going to say, that's gone, right? There's no chat history for voice, right? And so you need some way to go back. So it should be able to always repeat what it said. Similarly, you should always be able to say, what do you mean? And get some kind of paraphrase of what it just said. This is a little bit like local help, right? Help with that individual turn. And I showed how you can make that efficient by starting off with a concise version of the utterance, and then having the long, clunky one only if the user needs it. What do you mean? Okay, now I'll give you the long, clunky response that I don't want to give to every user. Or can you give me an example? Or what do you mean by porridge, right? These are three different types of paraphrase repairs. But what do you mean? That's sort of the most generic one. 4, okay and thanks. There's others that work as well, but these are kind of very easy to remember. They close the sequence. It's a little bit like closing a window, right? When you're done with booking your ticket, you say okay or thanks. That should show the system that I'm done with that. I got what I want and I want to move on. Now, for most systems, they don't even recognize okay, right? You need to make it actionable. You need to do the right thing if the user says okay or thanks. And Alma will move on. We'll see it as a sequence closer and move on to something else. For example, is there anything else, et cetera, et cetera. Or in contrast, never mind, right? This is a way to abort the sequence if things are going poorly. It's a little bit like the escape button. How do I get out of this? It's not working. Maybe I tried to repair it a couple of times, and either the agent or the user is still not understanding. You need to get away. You need a way to get out of that process, and that's how we do it in natural conversation. And finally, goodbye, or well, just have the user remember goodbye. They could say, I got to go, or all kinds of different things. But teach them that the system can do closings. And this is a little bit like quitting or logging out, right? You can't make the user quit or log out, but if they do, there's certain things you can do. At the very least, it's a good data point, and it tells you they ended the session, but there's other things you can do if they do that. So, like I said, you can't make them close the conversation, but if it's working like a conversation, they probably naturally do it. I mean, that's the point with all of these actions. Currently, users don't expect today's natural language interfaces or voice assistants or chatbots to do this, so they don't do it. They don't expect it, because if they do it, it doesn't get a response. But they all know how to do this. We do this all the time, right? It's familiar. It's like the direct manipulation of objects. This is familiar from how we naturally speak. So I think it's very easy to learn, but we have to teach them. I think we too often make the mistake of saying either at the one extreme, just talk to it like you would in a natural conversation, or just talk to it like you would to another person, and then they just go off and they do anything, and our systems aren't that good, right? So that fails. Or we don't tell them anything, and they default to assuming it's a search engine, and they just put in keywords, and they never say thank you, and they never say what do you mean, and they never give this, they never do this range. So we need to have some kind of tutorial, and we've struggled with this a bit. We found that they don't automatically know this, although if you look at Dashbot, that Dashbot does a lot of analytics on chatbots and voice assistants. A lot of these actions are things that people most often say, but we need to make them actionable, and we need to teach them that they'll have an effect. So that's the navigation method. And that's my overview of the natural conversation framework. We just published this 2 days ago. Our book, Conversational UX Design, that I wrote with Rafael Arar. He's a UX designer who unfortunately just left IBM and went to Khan Academy. But he was my partner on that project. The book just came out in the ACM Digital Library 2 days ago. I'm afraid I don't have copies today. I was hoping to have copies ready, but we were a little too slow. But that's ACM is Association for Computing Machinery. It's currently in their digital library, and they tell me in the coming weeks it'll be available on Amazon as well. But this is the practitioner's guide. Here, it's got the pattern language. It's got 3 chapters explaining each of the patterns. It's got the principles I talked about and concepts. And so we've tried to put all that into a form that practitioners can use. We also have a chapter on design thinking and how you can adapt the design thinking process specifically for conversational interfaces. So I hope you check that out. If you have any trouble finding it, send me an email, and I'll try and hook you up or try and solve that. And with that, thank you very much.